Today what we're going to be looking at is the last section of 6 that we're going to do, and we are going to be solving square roots and other radicals. So there's a whole bunch of different types, but the nice thing about this process is it's actually nothing new. Everything we're doing is inverse. We undo, we undo, we undo. So by way of getting ready, let's look at this warm-up. You're a passenger in the car, and here's the car going along the road. And here's a cell phone tower that's 3 miles away. The tower has an effective range of 6 miles. So you can keep driving until you get to that 6 miles, and then you will lose all connection. So how many miles do you have to finish your call? Justify your answer. So you're currently 3 miles away now, and ultimately what we need to do is get and show, so we have this many miles to go until something is 6. What's the 6? From the cell phone tower to my new location has to be 6 miles. So anything along the red is what I can travel. Anything along the red is what I can travel until this point here. So what kind of triangle do we end up having? A right triangle. So effectively, we can set this up using Pythagorean theorem. So using Pythagorean theorem, we can say this: 6 squared is my 6 is my hypotenuse, equals 3 squared plus my unknown distance squared. Now, as we start to set this up and solve it, here I get 36 equals 9 plus d squared. Now I get 27 equals d squared. And of course, now we have to take the square root. So we're going to undo the square there and square root that. So in the end, d is about 5.2 miles to go. Now, if you're traveling 60 miles an hour, that's 1 minute a mile. So that's less than 5 minutes to finish the call. But this highway looks pretty desolate, so my guess is someone's traveling much closer to 100. So what we're going to be doing is looking at problems like this, but instead of dealing with squares necessarily, we're going to be dealing with square roots and undoing those. So by way of vocabulario, what we're going to do is define a radical equation is an equation that has a variable in the radical, or in the radicand, so inside, it's under the radical, so it's part of the radicand, or the variable has a rational exponent. Because remember, a fraction in the exponent, a rational exponent, is effectively a root of some sort. So the first type is a very straightforward one. Notice our goal ultimately is to isolate the x. We're trying to get the variable by itself. So always use your x as a starting point and decide what to do. Notice x is being quadrupled, so at some point I'm going to divide by 4. The 4x is being squared, so I have to undo the square. And all of this has plus 2, so I have to undo the plus 2. So the inverses, going backwards, I'm going to undo the 2 first. So my goal is to isolate the variable. I'm going to isolate the variable. So how do I do that? First I'm going to subtract 2. Now we carry things down. I have the square root of 4x equals 6. Now, I need to take the square of both sides. I do want to pay attention to where my radical begins and where it ends. The radical intentionally stops, look, above the x. That's its endpoint. So it does not include the plus 2. So that's why I can subtract 2, because subtract 2 is not part of the radicand. It's not under the radical. So now when I do this, I end up with 4x is equal to 36. So what did I do here? I squared both sides. Why did I do that? Because it was undoing, it's the inverse of the radical. And now, my last step here, I need to get rid of the 4, and so x is equal to 9. So I divided by 4. Everything I'm doing is to isolate the variable. So I look at the variable, what's closest to the variable. Notice the times 4, that's the last thing I did, divide by 4. I have the radical, and then this plus 2 is outside. So essentially the farthest thing that's happening from the x is the first thing that I take care of. I don't divide, I don't square. What I need to do is get rid of that first. In other words, I'm undoing the order of operations. I'm undoing the order of operations. Okay. Take a moment, please, to do the practice here. All right, now let's look at another example. The same idea here. It's very important to pay attention to see when your radical ends. My radical ends here, so that means the plus 2 is outside the radical. So in this case, I'm going to subtract 2 first. So 4x plus 3. Notice when I write it, I need to go back and finish it. Look, the radical has to go above the 3. So don't let your laziness or anything stop you from having correct answers. Next, now the radical is isolated. The radical is all by itself, so I can undo the radical. So when I do that, I get 4x plus 3, and I square that side to get 9. So step number 1 is I subtracted 2. Step number 2, I squared. But that's not always what's going to happen. I'm just saying once you isolate the radical, you have to undo the radical. Now, this is a two-step equation back from Algebra 1. So I'm going to subtract 3 from both sides to get a 6, and divide by a 4 to get 3/2. So subtract 3 and then divide by 4. I do want to walk through a quick check on this one. The 2/3, the 3/2, excuse me. When I substitute a 3/2 here, I get 4 times 3 divided by 2, so that gives me a 6. 6 plus 3 is 9. The square root of that is 3. Add 2, we do get 5. So the check works out. This answer here is 17. Now let's check out what it is if we have a radical exponent rather than a rational exponent rather than the radicals here. So there's a couple different ways to approach this, but let's just start with this one. Notice that this entire binomial is being raised to the 3rd power. So how do I undo to the 3rd power? Well, all you have to do is raise all of this up here to the 3/1. Effectively, I'm cubing both sides. I'm cubing both sides. So when I cube this side, I'm left with x minus 2. That's it. Over on this side, I get 125. So since my exponent over here is the only thing there, I can inverse that. My last step is just to add 2, and I'm done.
And you just get rid of the parentheses.
We'll just walk through a check in our final moments together. So what we need to do is take the 127. We're going to substitute it into there. So 127 minus 2 cube root equals 5, question mark. And then we get 125 cube root equals 5. And the cube root of 125 is 5. And there we go. The last problem we're going to look at for today, instead of having all parentheses, now we have to isolate first. So I do need to get rid of everything that's around this so I can inverse the exponent. So notice I have a times 4 and I have a minus 5. So first I'm going to add 5 to both sides. So we end up getting 108. Now I'm going to divide by 4 and end up with 27. Now what we have to do is the sneaky part. We need to take this whole thing and raise it to the reciprocal power. So not 3/2, but 2/3. So whatever I do to one side, I need to do to the other. So effectively, a power of a power here means these two exponents will multiply, and when they do multiply, they reduce to 1. So I'm left with x. Yay! So now this one here, I can either square the 27, then take the cube root, or I can take the cube root and then square it. So the cube root of 27 is 3, and then squaring that will give me 9. And there we go. The check, of course, we can do a quick check here, is 9. The square root of 9 is 3, and when we cube that, we get 27. 27 times 4 is 108, and 108 minus 5 is 103. And we're good to go.